And welcome back to IV Tutor. We want to look at the insertion sort algorithm. If you haven't looked at the insertion sort at the selection sort algorithm, please check out that video. So the insertion sort algorithm, just like selection sort, also has a running time of n squared. You can go and read the textbook for a detailed explanation of the calculations. Our main focus, though, for the exams is to just learn how to apply the insertion sort algorithm, because that is what you are required to do, application of the algorithm. The insertion sort algorithm makes less comparisons compared to selection sort, but it does make a lot of movements. And what it does is, in summary, it picks an item from the second index and it tries to move each item towards the top of the array or towards the left side of the sublist until it encounters an item that is greater than the current item. So you keep moving an item towards the left until you meet an item that is not less than the current item, because if you keep on moving, then it means you're not sorting anymore. So the number of comparisons that insertion sort makes are much less than selection sort, but the number of movements that insertion sort makes is quite high. And let's just see how you would apply it. So if you've got a list that looks like, like this list here, you would start by looking at the second index, and then you say, well, can we move 18 up? In this case, you cannot, because, this is all, in this case, we have already applied insertion sort for these three here, and we are now looking at this index, which means we have already looked at the second index, we have looked at the third index, we have looked at the fourth index. Now we are looking at this fifth index, and we are looking at 23. And what you try and do is you try and move 23 upwards until you meet a number that is greater than 23. So 30 is less, which means 23 keeps moving, 25 is less, 23 keeps moving, but 18 is less than 23, which means you cannot move 23 past 18, which means 23 needs to get here. So what you do is you pretty much have to move 23 until it gets here, and all the other items shift to the right. But the way the actual algorithm works is you simply copy 23, then you move 30 to here, and then you move 25 to here, and then you move 23 to there. So after these two movements, and that is why insertion sort makes a lot of movements, because you're going to have to move 30 to 23, you're going to have to move 25 to 30, and then after that, you then move 23 to this index. But in terms of applying the algorithm, all you are doing is just keep moving 23 upwards until it cannot move anymore, which means until you meet a number that is not less than 23, and then you stop. And everything else shifts downwards in this case, or to the right if it's horizontal. For example, let's look at this one here, and let's try and apply insertion sort, which means you're going to start by looking at 67. And you try and move 67 to the left until you meet a number that is not less than 67. In this case, you cannot, because 34 is already less than 67. So you go to the next index, and then you look. So after that, you still have 34 here, 67 here, 23 here, 12, 78, 56, 36, 79, 5, 32, 66. And now you look at this index, which means you try and move 23 to the right. And yes, 23 should move past 67 and past 34, because these are all greater than 23. So 23 should move to here, which means, in other words, 23 moves to there, then all these ones shift to the right. So it now looks like this. That is how you apply insertion sort algorithm. And you keep doing this. Now you look at the next index, which is a 12. You move your 12 to the right, to the left, until, so it passed 67, past 34, past 23, so it needs to go there. So that means your 12 is going to be here. Everything else shifts to the right. So 23 goes there, 34 goes there, 67 goes there. Now you've got 78, 56 here, 36, 79, 5, 32, 66. Now you look at this one, 78 cannot even move once because, well, this is not less, so that's done. So after this iteration, you still have 12 here, 23, 34, 67, 78, 56, 36, 79, 5, 32, 66. Now we look at this index, 56. Yes, 56 can move past this tree here. So that means you have 12 here, 23 here, 34 here. Now your 56 is here, and 67 and 78 move to the right. Then you have 36, 79, 5, 32, 66. Then now you look at that index, and surely it can move. So you are going to have 12 here, 23, 34. Your 36 is going to move to here, and then 56 is going to shift rightwards. 56, 67, 78 will all shift. Then you have 79, 5, 32, 66. Now you look at the next index. So just keep on going index by index to the next index. 79 cannot move, so that's done already. 23, 34, 36, 56, 67, 78, 79, 5, 32, 66. Look at the next index. 5 is going to move all the way to the left. So 5 is going to end up here, and everything is going to shift to the right, which means 12 is going to move to here, 23 to there, 34 there, 36, 56, 67, 78, 79, 32, 66. And now your next index is 32, which is going to move all the way up to here, which means you are going to have 5, 12, 23, 32. Then everything shifts. Then you have 34, 36, 56, 67, 78, 79, 66. And then you look at your last index. 66 can move to here. So now you have 5, 12, 23, 32, 34, 36, 56, 66. And now these ones shift. So you've got 67, 78, 79. And you've gone through every single index. So that's how it works. And that's it. So these would be all the iterations required to sort this list using insertion sort. So basically that's it. I don't think I want to do a lot more examples. It's exactly how you apply it. So you simply start from your second index and you try and move that to the left, and you keep going every index by index until you get to the last index. And that's it. So no way to start, no way to stop, because with selection sort, remember, you don't process the last item once you're left with one, because it works differently. And once there's only one item remaining in your unsorted list, you stop because an unsorted a list with one item is already sorted. But with insertion sort, you keep going until the last index because it could potentially move to its rightful position. So that's how you do insertion sort. And you just have to find more examples, practice, and that's it. So these algorithms are not very difficult to apply. Obviously, it's a different story if we talk about application or implementation of these algorithms using linked lists or using arrays. But in this case, we are not bothered with that detail. We simply care about, can you apply it given a collection? How does the algorithm process the array, or how does it sort the array? So just to do a quick recap, you should have looked at the quick sort algorithm, make sort algorithm, insertion sort algorithm, and selection sort algorithms. Those are the 4 main algorithms that we worry about, and you should practice, and that's it. So that's it on sorting algorithms. These are not the only sorting algorithms available, but these are the ones at least that we look at, and which means from here we should now move on to the next topic, and I'll see you there. Cheers.